Welcome to the first video lecture for Fund 1. As you can see, it is on scientific notation. And in case you haven't come across before, that is just a system for writing numbers that we use a lot in physics. So numbers have two basic properties. So for example, these three numbers. These guys are the same size. So that's one property they share in common, but they do have different significant figures. And remember, significant figures are those non-zero numbers which aren't on the back or on the front. So for example, these guys, not significant figures, but these guys are significant figures. So these two are the same size, but they have different significant figures. And these two, the first and the third one, have the same significant figures, but they're different size. This one's really big and that one's really small. And so scientific notation, we take those two properties of numbers, the significant figures, and the size, or the power, or the order of magnitude is often what we call it in physics. And we assess them out and write them separately. So if we were going to write a number in scientific notation, we'd write the significant figures, and then we'd write the size as a power of 10. So the order of magnitude goes there, the significant figures go there. So if you're going to write these three numbers, what we'd get is, well, the significant figures, that's the 1, the 2, and the 3, be 1, 2, 5. So, and usually for scientific notation, we put only one of the numbers in front of the decimal place, so 1.25, and then we'd write the size, which is 1, 2, 3, 4, 5. So if we're writing as a power of 10, it would be 10 to the 5th. And this number would be, its significant figures are 3, a 1, and a 7. And we'd then write out its size, 1, 2, 3, 4, 5. So yep, same size, those two numbers, but different significant figure. And this one, the significant figures are where else 0, 0, 0, and then 1, 2, 5. So same significant figure as the first number, but a different power. And here it's small, so it's going to be a negative power. And it's 1, 2, negative 2. So that's how we write these guys. Why do we like it so much? One, it lets us deal with really big numbers or really small numbers, which we have to do a lot of in physics. And two, it gives us some tricks to do easy math. So if we're going to multiply, for example, if you've got two numbers and they're in scientific notation, maybe one, we'll write its significant figures and just call them A, and then its power, we'll call it N. We're multiplying it by a number, which will have significant figures that we'll just call B, sub them in for that. And its power will be m, then because for multiplication, you can just multiply them in any order you'd like. We'd multiply the significant figures together, and then we'd multiply the powers together. And because they're both exponents of 10, we can just add those exponents. So it would be n plus m. So as an example, if we had 4 times 10 to the 7, and we were multiplying it by 2 times 10 to the 3rd, well, we'd multiply the 4 and the 2 together, and then we deal with the powers, so that would be 10 to the 7 plus 3, and we'd get 8 times 10 to the 10. Oops. Sorry, hard to write and talk at the same time. And we could, of course, write them out in standard notation. So 4, 7 zeros, 1, 2, 3, 4, 5, 6, 7. And 2 and 3 zeros, 2, 1, 2, 3. And you could do that, but that's just like too many zeros to keep track of. So we don't do it that way. We do it this way instead. And a similar thing happens when you divide. So if you have two numbers in scientific notations, A2 times 10 to the n, and b times 10 to the m. Then we divide the significant figures. And because we're now dividing powers of 10, we subtract those exponents. So it's n, power on top, minus m, the power on bottom. So using those same numbers in the previous example, 7 times 10 to the 4 and 2 times 10 to the 3. Sorry, I screwed up what I said there, but follow what I've written down. We do 4 divided by 2. And then dealing with the exponents, it would be 7 minus 3. So this guy would be 2, 4 divided by 2, and then 7 minus 3 is 4. And there's our answer. The only tricky thing is if you've got a small number and then the exponent's negative. So there, if we're doing that and we're multiplying, say it's 4 times 10 to the 7 times 2 times 10 to the negative 3 this time, then we'd still have 4 times 2 and 10 to the 7th, then it would be plus, but we're adding a negative number, so really it's minus. So that would be 8 times 10 to the 7 minus 3, or 8 times 10 to the 4. Similar when you're dividing, 4 times 10 to the 7 divided by 2 times 10 to the negative 3, that'd be 4 over 2 times 10 minus negative 3, and minus a negative number is plus, so that would be 2 for the significant figures, and then 7 plus 3 is 10, so that would be our answer. So just watch the negative numbers, they're a little tricky.